first law of motion, and that law of motion is known as law of inertia. Law of inertia. So the first law of Newton's. So what is the first law of motion? This is known as Newton's first law of motion. Or another word we call it law of inertia. Okay. Newton's first law of motion, or we call it as law of inertia. Now what do you mean by law of inertia? Okay. Have you ever studied in 6th standard or anywhere the word inertia, children? No? It's the first time you are listening this. Anyone? Anyone has heard about the word inertia? I think in some small classes or something, have you heard? 6th or 7th? I don't think so. No, no idea. Okay. Now what do you mean by this inertia? Inertia means it is an inherent property. Inherent property of a material to resist any change. So what do you mean by that inertia? It is the inherent property. It is the inherent property of a material to resist the change of rest or motion. Inertia is the inherent property. Inherent property means every material is made up of chemical things, that means atoms, correct? So every atom has its own property. So this is one of the property. It is by nature they are like that. Okay. So if you want to change, suppose a car is moving on a straight road. In order to change its direction or something, we need to apply a force. Without applying the force, it will not change. And even if the car is changing the direction, frictional force is resist that motion. Okay. So that is the property. Even our body, all non-living and living matter. We are matter made up of chemical things, chemical atoms or molecules. So all living and non-living matter has this property. So it has inborn property, that is inertia. And it is clearly depends upon the mass. So inertia is the measurement of mass. Inertia depends upon mass. Inertia depends upon mass. That means mass is the measurement of inertia. Mass is the measurement of inertia. Mass is the measurement of inertia. What do you mean by mass? Mass is the measurement of inertia. Clear? For example, we can just say, talk about this table, wooden box, and there is this table and there is a heavy wooden block is there on that. Okay. Now, suppose this wooden block is, instead of wooden block, we keep an iron block. Correct? Now, in order to move the iron block, I want to ask Gautam. Gautam. Okay. Gautam, you have seen the table and there's a top, there's a wooden block. Suppose instead of wooden block, I kept an iron block and you removed the iron block. Then I kept the wooden block also. Then you remove the wooden block. Now my question is to you, in both activity, in which action you use the more force? Either to remove iron block or either to remove wooden block?
To remove iron block.
Iron block. Why did you use the iron block more force?
Because it weighs more.
Heavy. Correct. Yeah,
Yes.
correct. So this is that. So Gautam has applied more force in order to shift the iron block than wooden block, because iron block has more mass than wooden block comparatively, because iron block is a metal and it has more mass, whether it's the same size, both can be same size, same breadth, same length, but iron block is clearly made up of iron molecules and they are very heavy metal, while wooden block is a natural wood of the tree and it has dried one and it may not have the same mass just like iron block. So that is the meaning of mass is the measurement of inertia. Correct. Similarly, a heavy wooden box, a small wooden box. Just think to remove heavy wooden box or light wooden box, you apply more force. Jocelyn, a heavy wooden box and a light wooden box. On which box you need to apply more force? Heavy or light? Yeah, heavy wooden block, because heavy wooden block has more mass than light wooden block. Okay, that means material can be same, but depending upon how much is the quantity of that block, it will change. So that is what the Newton's first law. So on the basis of Newton's first law, we can state so what do you mean by Newton's first law of motion or law of inertia? Anthony Maxey, can you read which is on the yellow one? Just read it. What is that?
An object
An object remains. What happened to your audio? Arun, can you read? Can you read that one?
An object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force.
Yeah, by an applied force. So this is Newton's first law. You can write it down. So Newton's first law of motion or law of inertia. Your I is there, okay? That has missed out when I. Law of inertia. INERTIA. An object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. I can zoom in for you. Just want to read it. It is too much for you. And what is this applied force? Actually, applied force is unbalanced force. An applied force means it is unbalanced force. Sometimes we use the word external force, all that. These are the some terms we mainly use. Unbalanced force, external force, or applied force. Okay, students, you can see it's a beautiful girl, a small girl child, and she is skating. But she is not skating, simply skating like you. You can see that on the skating board, she has kept a suitcase. And she balanced her body on the suitcase and she is moving in a constant straight line motion. As long as no external force acting on that girl, she continue move in a straight line motion. And some of you, if you present there, some of you, maybe some of your boys, some of you like to do some mischief. Maybe you push that girl, so she lose the balance. I mean, she lost the balance and she can fall down. So that is unbalanced force. So Newton's first law states that a body remains in a state of rest. Suppose you are on your chair, you remain there for a long time until someone come and push you. Similarly, a body motion in a straight line. So just like this girl is skating lying on the suitcase on the top of skating board, and she's balancing herself by stretching her hand, and she's moving in a straight line because of this. Unless we don't apply any force on her, she will be continue moving it. Okay, so suppose this word inertia is not there. What is the relation between inertia and this? Because this body continued to move in a straight line because it doesn't want to change. That is the inertia. Her body or herself did not want to change her motion, so she continued moving it. Just like a ball, you throw a ball, it is rolling on a plain surface. Suppose the surface is very smooth and polished, the ball will be continue moving it. The ball will continue moving it. Okay. But if there is a frictional force, just like our Kerala road, just like our Kerala road, you know it. Okay. There are a lot of gutters, gutter and potholes now because of the rain. One rain is enough, our Kerala road become potholes. Can she skate it there with the same way? Can she skate, Sriram? In the picture you saw, can she skate on the Kerala roads, Sriram?
No, ma'am.
Now, why? Why?
Full of
Full of potholes. Full of potholes and gutters, we say locally. And what happened? Because of the potholes and gutters, which force will act like unbalanced force?
Gravitational.
Gravitational force? Is it
Frictional.
more predominant there?
Frictional.
Frictional force. Okay. If this road is not smooth, if there are full of potholes and gutter, frictional force act on that body and it will become an applied force. There, Newton's first law may not obey. Okay. So, Newton's first law has to obey if there is no external force. So, that's the meaning of unless compelled to change that state. That is the word. If you don't apply unbalanced force, the body will continue move on a straight line just like this girl is skating. So this is known as Newton's first law. Okay. Similarly, we also have some life experience. Have you ever experienced in the bus? Suppose you are on a crowded bus. Just imagine you are on a crowded bus. I just ask to who else? Bastin. Bastin, don't off the video, on the video. When I ask the question, why are you offing? Okay, Sania, Jin, everyone, on the video.
Yeah,
let me see.
Anandu.
Yes. Good morning, sir.
Good morning.
Yes. Dominic, Karthik, Swadi, Krishna, Elsa, Shania. Yes. Bastin, I'm just asking you a question to you. Now you are in a crowded bus. Okay. And the bus is going with maximum speed. And now the bus driver suddenly applies the brake. In which direction you will fall?
ma'am, question one more time.
One more time. You are traveling on a bus. Okay. Bus is crowded and you are standing on the bus. Clear? Suddenly the driver applies the brake and bus was maximum speed. What will happen to the motion of yours? Suddenly the bus applies a brake. What will happen to you? That's my question. Will you stay in the same position when driver suddenly applies the brake? Just think about, imagine you are traveling in a bus. Then only you would give me the answer. Raju, Bastin, video. Ah. You have never traveled in bus, Bastin?
Yes, ma'am.
And then tell me. When the bus suddenly applies a brake, what will happen to your position or your motion? I'm giving a lot of clue to you, whether you will stand in the same place or not. Tell me. It's be wrong or correct. You have to open your mouth. Then only I
We
can
will fall.
understand now. You will?
Fall.
You will fall. Very good, very good. That's what I wanted. Okay. Fagat, when we apply the brake, in which direction we usually fall? I can't hear your. Ah? Keep your mic close to your mouth and give me answer. Yes? Are you saying I can't hear you? I think she is facing network issue. Sania, Jinu, can you tell me? When you apply the brake, Bastin already told will fall. Okay. In which direction we fall? Forward or backward? Usually when the bus applies the brake.
Forward.
Forward. Forward.
Forward.
Okay, very good. Karthik, your video is okay? Can you hear me, Karthik?
Yes,
Can you
ma'am.
hear me?
Yes.
Yes. Okay. When you fall, will you fall? Your full part of your body will fall, only the front part. Front part means, I mean, it's upper part above the stomach. Okay. We divide our body into lower part and upper part. Above the stomach, we can say upper part, and below the stomach is lower part. So when you fall, which part will move forward?
Upper part.
Upper part. Then lower part will remain
In the ground.
in the ground. So this is a simple application of inertia. Now what is this? What does this mean? How do we explain how this law of inertia act on it? See children, when you apply the brake, before applying the brake, your body, your entire body in motion. Bus is moving, but your entire body in motion, but you don't experience it. You think bus is moving. But when you look at outside, you feel the trees are running away from you. That means you are moving with the bus. Okay, your platform on the bus. So suddenly bus applied, the driver applied the brake. Now what will happen? Your upper part continue in the motion, but lower part suddenly comes to stop because the bus applies the brake. Are you getting me the idea? When you are in the bus, while bus is in the motion, your entire body in motion with the bus. Clear? And your body has your own inertia. That is, you resist any change. That is inertia. Correct? So suddenly, bus applies the brake. Only your upper part move forward, but lower part remain in the bus itself, in state of rest. So, your upper part did not want or does not want to come in a sudden stop position or sudden rest. It doesn't want to come in rest. That's why your upper part continue moving it, even though bus stops. But your lower part is at rest with the bus. So this is an application of law of inertia. Did you get that idea, my dear children? Similar thing happened to us. Okay, now bus stopped. Now the driver starts the bus again. Shania, when driver suddenly starts the bus, before that you are at rest position in the bus. Now driver suddenly start the bus. How will be your motion in that? In which direction you fall? Forward or backward?
Forward.
No. Bus now start. Backward. Correct. You are saying correct, but mistake came forward. In that case, which part moves backward? Upper part or lower part? When bus suddenly starts moving, okay, I just asked to Kshetra. Yeah, Kshetra, give me answer for that. So when bus suddenly starts, your upper part move backward. Now, here, how this inertia applies on it. Can you explain? Yeah. What do you think so? Are you saying? I can't hear you.
Lower part.
Lower part remain at the, because your upper part is moving backward, no? So, but your lower part is still at rest, correct? Is that so? That's why you are moving backward.
Yes, ma'am.
Yeah. Anyone can tell me little more detailed explanation? Srihari, can you give me little more detailed explanation of that?
Ma'am.
Just try, no problem. We are studying
Ma'am,
first
when
time.
the driver moves the bus suddenly, we are our leg is already in the rest position.
Yes, very good, very good.
So when he starts it, the sudden movement, our upper body wants to move with the bus. So we don't have our balance and we fall down back.
Yeah. So did you get that idea, children? This is some simple application what we see in our daily life. Okay. When the bus is in motion, our entire body in motion. So when you suddenly apply the brake, you move forward, your upper part move forward, lower part remain at state of rest. Correct? Because upper part continue to be in motion, it doesn't want. It doesn't want to come to rest fast. Similarly, suddenly when bus was at rest, all of your body, entire body was in the state of rest. Suddenly, driver applies or starts the bus, your lower part remain in state of rest, but your upper part starts moving with the bus. So, lower part doesn't want to change the state of rest. Okay. So, this is law of inertia. Clear? So, similarly, I'll just go back to the slide. Go back to the slide again. Yeah, we wind up. It's time to wind up, but still I just want. The same thing happens here, children. This is the, I have showed you for unbalanced force. First two times when the balls are pushed, the box did not move, correct? But the third time, when we applied more force, it moved. Of course, frictional force is a factor, but it is also is the inertia of the wooden box. That's why toys, two times they were pushing, but the box does not move because box doesn't want to change its state of rest. Okay, but when these two boys applied more force, then third time the box starts moving. Okay. Okay, children. So we are winding up the session here. So I would like to ask Elsa, can you just tell me Newton's first law of motion fast before I winding up? Just say what you understand.
Ma'am, inertia.
Yeah, it's a law of inertia. Okay, what is inertia, Revu? What is inertia? Yeah, what is inertia fast, Revu? Time up.
Ma'am, it's
Just
the
say in your own words. It is the Revu, are you saying or you are saying? What is inertia, Revu? Fast.
ma'am. I just got a problem between.
You just ended.
I just got a problem.
Adulya.
Depend upon mass.
Yeah, repeat. I could not hear. Repeat, Adulya, once again. What is inertia?
I'm Shmuli, not Adulya.
What
Ma'am,
you
he
say?
answered it.
Upon mass.
What she said, Srihari?
Oh, no, ma'am. Hear it properly.
That's why I can't hear you. A little more louder.
Ma'am, it depend upon mass.
Depend upon mass. Okay. My question is, what is inertia?
Ma'am, it is a natural force made by an object to resist the state of motion.
Okay. It's more appropriate word is it is the property. not force, it is a property. Correct? It is a inborn property. Okay. So next class we will continue with more application, then you will understand better. So we have first law of motion. So inertia means it is the property. It is inherent property of the material to resist the state of rest or state of motion. Okay, children.